To optimize a modern manufacturing facility, engineers rely on real-time telemetry and the creation of live 3D digital twins. A digital twin is a perfectly synchronized virtual replica of the physical factory floor used to simulate and predict production changes. This diagram shows the standard Industry 4.0 architecture. To power these virtual simulations, the factory pushes vast streams of physical telemetry data up to external big tech cloud servers for processing. Routing this data externally exposes the operation to corporate espionage. Defense contractors and biomanufacturers cannot risk uploading proprietary production rates or highly classified CAD, computer-aided design, models to outside servers. The second failure point is simple physics. High-speed kinetic robotics rely on continuous, instant feedback. If an API, the software interface allowing the factory machinery to communicate with the cloud, requires a round-trip data request, it introduces latency. If that delay exceeds 5 milliseconds, the automated robotics will stutter or crash. When you are operating heavy machinery and manufacturing proprietary military hardware, relying on external servers guarantees the persistent risk of catastrophic machine failure or intellectual property theft. To achieve autonomous production safely, these advanced manufacturing facilities must physically sever their data connection to the macro internet entirely. The Sovereign Forge solves this paradox. It provides strict, localized latency control, ensuring a heavy-duty robotic arm instantly halts before a collision, rather than waiting for a delayed cloud directive. The package functions as an expansive, localized AI operating system. It entirely replaces the need for external cloud computing by bringing data center-level processing power directly to the factory floor. The system operates in strict island mode. There is zero physical egress to the outside internet. All proprietary workflows and simulations are trapped entirely on localized, encrypted NVMe drives, a specialized type of ultra-high-speed solid-state storage. Deploying this requires a $249,999 capital expenditure. That price covers a physical multi-pallet hardware fleet and dedicated architectural integration by dereticular enterprise engineers. This strict isolation is engineered specifically for plant managers, defense contractors, and biomanufacturing directors who operate under severe compliance and security mandates. The Sovereign Forge completely collapses massive cloud infrastructure into a secure, strictly on-premise hardware stack, ensuring absolute data sovereignty. Here is a 3D wireframe of an unnetworked factory. These 30-year-old machines are isolated analog islands. We install 250 industrial Foreman micronodes that snap directly into existing machinery control cabinets. These analog-to-digital bridges translate legacy protocols, OPC UA, Profinet, Modbus, into a unified AI network. They incorporate analog current and voltage readers. By monitoring standard 4 to 20 milliamp signals, the system digitizes strokes of older mechanical presses. The ingestion layer also deploys 50 specialized bioprocessing and silo nodes directly at the raw material intake base. These track moisture, volume, and biological metrics before the inputs hit the production line. By bridging both legacy analog systems and the raw material silos, the factory establishes a comprehensive data baseline capable of feeding a high-fidelity virtual simulation. Generating thousands of simultaneous IoT, or Internet of Things, data streams requires a heavy-duty, localized network to transmit that information securely. This top-down view shows 40 Nomad Forge points, generating overlapping rings to form a continuous coverage web. This canopy operates on ultra-low latency private 5G and Wi-Fi 7, passing seamlessly through structural pillars and dense heavy machinery. All of this telemetry is routed directly into the Forge brain, 2 high-capacity Sentry Pro clusters sitting in an air-gapped, climate-controlled data center. These are equipped with GPUs, graphics processing units, and NPUs, neural processing units designed to accelerate AI calculations. These rack-mounted clusters contain dual localized AI accelerator GPUs and 128 gigabytes of VRAM, the specific high-speed memory needed to render complex 3D environments. Together, they process millions of incoming data points every second. To secure this internal traffic, the system mints a custom Forge Root CA. A root certificate authority is a cryptographic anchor that verifies the identity of devices on a network. This establishes absolute trust between all 300-plus edge nodes without pinging an outside server. This combined infrastructure delivers the secure bandwidth and raw compute power required to render and update a real-time 3D simulation of the factory entirely on-premise. This isometric view highlights the system's spatial awareness layer. 15 Vault-Warden LiDAR arrays, sensors that use pulsed laser light to measure distances, project sweeping cones of light across the facility, generating a 3D point cloud simulation. These arrays continuously map the physical floor. This ensures the digital simulation is perfectly synchronized with the physical reality of moving inventory and personnel. This spatial map integrates with factory logistics. 20 Nomad fleet kits plug into the CAN bus of existing forklifts. Connected to the forge, these AGVs abandon magnetic line following, traveling through the 3D point cloud using dynamic spatial pathfinding generated by the digital twin. If a pallet of raw input spills on the physical floor, the Vault-Warden LiDAR detects the obstacle instantly and updates the virtual map. In response, the system calculates new vectors and routes all 20 AGVs to alternative factory aisles in real time, actively preventing collisions. By perfectly aligning the physical space with the virtual simulation, the autonomous transport fleet adapts dynamically to environmental chaos without human intervention. This timeline illustrates Sentry Pro Edge Logic controllers analyzing IoT data to trigger sub-millisecond responses. If a vibration sensor detects an anomaly on a press, the data packet hits the edge node, instantly returning a command signal that cuts power at exactly 12 milliseconds. In that fraction of a second, the local node cross-references the digital twin, determines the bearing is failing, and triggers a localized GPIO relay, a standard electronic switch, to halt the press. It prevents a catastrophic mechanical failure entirely on its own. Beyond kinetic machinery, the Sovereign Forge integrates directly with the human workforce, utilizing the Sovereign Executive Factory Clinic node. This provides an isolated AI medical database that strictly complies with HIPAA, the federal law protecting patient health information. It allows the clinic nurse to log occupational health injuries and generate compliance reports for OSHA, the National Workplace Safety Agency, entirely via voice-to-text. On the floor, managers access 5 ruggedized touchscreen kiosks. From here, they can query the Deep Admin LLM, a large language model trained specifically on the factory's documents, to pull up maintenance runbooks or identify real-time production bottlenecks. The system natively groups machinery orchestration, predictive maintenance, human administration, and strict safety protocols into a single offline ecosystem. Due to its extreme scale, acquiring the Sovereign Forge requires a highly coordinated hybrid fulfillment workflow. This flowchart maps the deployment. The first phase is ingestion. Before any hardware ships, Reticular engineers securely load the client's CAD models and BIM data, building information modeling files that detail the facility's physical architecture into the Forge clusters to pre-calibrate the digital twin. In Phase 2, the GPU clusters undergo a rigorous 72-hour thermal and VRAM burn-in test, simulating peak IoT data ingestion. Once verified, the hardware is packed into shock-proof transit crates and dispatched via dedicated multi-truck LTL, or less-than-truckload, freight. Phase 3 is physical deployment. Factory electricians bridge legacy machinery nodes, engineers flash the AGV fleet kits, and the core GPU clusters are finally racked and ignited in the facility's air-gapped data centers. This rigorous physical integration ensures the Sovereign Forge permanently scales the facility's operational capabilities from the ground up. The final result is a complete physical break from vulnerable cloud reliance, granting the facility absolute localized control over its manufacturing environment. Housed entirely within the building is the power to manage thousands of legacy sensors, orchestrate heavy autonomous transport fleets, and render a live 3D simulation of every action on the floor. Plant managers precisely tweak parameters on the simulated lines, using the AI to predict the impact on material intake and output before pushing a single physical change to the actual machinery. The core value of the Sovereign Forge is the ironclad guarantee that advanced manufacturers can fully optimize their production without surrendering a single byte of proprietary data to the outside world.